Hello Math 1 students. This lesson is an extension of the previous lesson and it's on 8.c, which is I can write an equation for a linear function, but this time you're going to be given the slope and a point. Now what you see here is there are two equations given to you. One is in point slope form and one is in slope intercept form. Now you have to understand that these two equations, they are equivalent. If I took the y minus 6 equals 4 times x plus 3, and I go ahead and simplify this and solve for y, right? I distribute the 4 to get 4x plus 12. Then to get y by itself, I add the 6. What you notice is I end up with 4x plus 18, showing that these two equations are equivalent, meaning they're the same equation, just written differently. Now we know right away from looking at the second equation that this here is the y-intercept for the function. And if I look at the table, that point is very clear. So now if I go and look at the point slope form, and remember, point slope form is always y minus y1 equals m times x minus x1, where what you have to notice is y1 and x1 are your points, or make up your point, and then m is your slope. But when I look at the table though, right, if I go to 3, 3, negative 6 is not, like we don't see that point on here, but what we do see is we see negative 3, 6. And what this allows us to do, you got to remember, in point slope form, it's y minus y1. So any number we plug in, the sign's going to change, okay? And since it's x minus x1, any ordered pair we plug in, the sign will change. So when I pull the number out, right? So if I look at x plus 3, I know the ordered pair is going to be negative 3. And since it's y minus 6, the opposite of negative 6 is positive 6. So what you have to understand is this ordered pair, negative 3, 6, can be taken from here. Now, if we were to write this equation, what you have to understand is if I did y minus the y coordinate 6 equals 4 times x minus, what am I subtracting? Negative 3. But then when I go ahead and make that a plus positive, that's where the x plus 3 comes in. So if we had to, after observing the functions in the table, how would you write the equation of a function in slope-intercept form that passes through 3, 5, and has a slope of 5? Well, the first thing we're going to do to write it in slope-intercept form is actually just write it in point-slope form. So the first thing we're going to do is basically always find the slope. But the second step now is going to be to plug the slope m and a point on the line, which we are going to call the x1, y1, right, into point slope form. And that is y minus y1 equals m times x minus x1. So right away, let's go ahead and start this problem off. We know the slope is 5. And we know our ordered pair is 3, 5. So we know x1 is 3, y1 is 5. So we're going to take these and plug them in to the point slope form. So y minus y1 is 5 equals m is 5 times x minus x1 is 3. So right now this here is point slope form. Then all we're going to do last is distribute the slope and solve for y. So all I do is I come over here, distribute the 5, so y minus 5 equals 5x minus 15. Then all I'm going to do, solve for y by adding 5 to both sides. y equals 5x, then negative 15 plus 5 is negative 10. So this here would be your slope-intercept form. Okay, so looking at the couple of examples here, right? Point slope form becomes your best friend, and that's key, right? Because no matter what, you can stop writing an equation with just point slope form, or you can continue and put it in slope intercept form, either one. So right away here, when we look, you have to read the directions here. It says write an equation in point slope form for the line whose slope is 2/3 and passes through 4, 7. So right away we know m is 2/3 and our point is 4, 7. So all we do is plug all of that in to point slope form. Y minus y1 equals m times x minus x1. So y minus the y coordinate order pair is 7 equals the slope m 2/3 times x minus x1 is 4. I don't have to do any simplifying, so there is the equation written in point slope form. So next, write an equation in point slope form. So right away we notice that that's the form we want to write in, whose slope is negative 14. So right away, m is negative 14 and passes through this point, negative 6, 10. So y minus y1 is 10 equals negative 14 times x minus, you got to remember, x1 is negative 6, so when I subtract negative 6, you have to remember that becomes x plus 6. So my final answer would be y minus 10 equals negative 14 times x plus 6. And leave it in point slope form. Now the next example does ask for it to be written in slope intercept form. Okay, so the first thing we're going to do is take our slope of 7 and our point, right, and plug it in point slope form. So y minus y1 is negative 2 equals, my slope is 7 times x minus x1 is negative 3. And right away, I like to say bling bling. If I'm subtracting a negative, I make it plus positive. I'm going to bling bling here. So now, that's point slope form, but they want it in slope intercept form. So I actually have to distribute the slope here. So I'm going to go ahead and distribute the 7. So y plus 2 equals 7 times x is 7x. 7 times 3 is 21. And now I'm going to solve for y by subtract 2, subtract 2. That would give me y equals 7x. 21 minus 2 is plus 19. All right. Now, number 4. Write the equation in slope-intercept form. So right away, we again notice slope-intercept form. But even more important is you're given the value f of 8 is equal to negative 4. What ordered pair can we gather from this? This is your input x. This is your output y. So 8, negative 4 is the point we have. Now, the slope is negative 9, so m is negative 9. So we start with point slope form. Y minus y1 is negative 4 equals negative 9 times x minus my x1 is 8. I do have to bling bling here, so that becomes y plus 4. But now, since I'm writing it in slope-intercept form, I'm going to distribute the negative 9. So y plus 4 equals negative 9x plus 72. Go ahead, subtract the 4, and y equals negative 9x plus 68. And that would be the slope-intercept form for that line. So now, the next one says, write an equation for the line whose slope is 5/9. So it doesn't specify what form to write this in. So you have an option. You can either go slope-intercept or you can go point-slope form. But the slope of it is 5/9 and it goes through this point, 12, -7. Now, personally, if I'm going to have to do anything with distributing a fractional slope, I'm going to just write my answer in point-slope form. So if you said, I'm just going to write this in point-slope form, y minus -7 equals my slope 5/9 times x minus 12. I would just stop here, right? That would just be me, okay? Because, or actually you can't stop there because I got to change that to plus positive. Oop. So, right, I would write my final answer just as y plus 7 equals 5/9 times x minus 12. Distributing that fraction is not going to always be nice. Now the next one does say write an equation in slope-intercept form for the line that passes through this point, right, and has a slope of -1/4. So I'm going to start this in point-slope form no matter what. So y minus -6 equals -1/4 times x minus -8. I do have to bling bling twice here. Bling bling here, bling bling here. So y plus 6 equals, I'm going to go ahead and distribute the -1/4. So -1/4 times x is -1/4 x. Then -1/4 times 8. That's going to give me -8 over 4, which is -2. Now, subtract the 6 from both sides. In the slope-intercept form, -1/4 x minus 8. So do me a favor, go ahead, do the work on the student practice, and let us know if you have any questions.